Hello everyone, I want to talk to you briefly about linear functions. So I usually use y-intercept form, which is y equals mx plus b, where m is the slope, change in y over change in x. Should get you there for what you've done in high school, and then b, 0 comma b is your y-intercept. Some of you guys may be more comfortable with using y minus y1 equals m times x minus x1, which is point slope form. I want to go over one problem to find the equation of a line where they're giving you 2 points, and this is directly from your notes, so I'll show that to you now. Okay, it's this problem right here where they give you the point -1, 1 and the point 4, 11. Okay, so if they're giving you -1, 1 and also the point 4, 11, in order to find the equation of the line that runs through that, then you have to keep in mind that in order to find the equation of any line, and I do mean any line, you need 2 things. The first thing is a point, any point on the line. And then the second thing you need is the slope of the line. Alright, so in this particular example, they've given you 2 points. -1, 1 is your line is going through that, and your line is also going through the point 4, 11. So that takes care of criteria number 1. So for criteria number 2, the slope of the line, you remember from the earlier videos, you can find that by doing change in y over change in x. So this is 11 minus 1 all over 4 minus -1, which is 10 over 5 or 2 over 1. Okay, so let's tie all of that together and put it back into y-intercept form. So if we do y equals mx plus b, and for the slope now we're plugging in 2, or 2 over 1. And then as I mentioned, it doesn't matter which one of these 2 points you use. So I'm going to use the point 4, 11. So 4 for the x equals 11 for the y. Of course there's a plus b on the side. So then 11 equals 8 plus b. Subtract 8 from both sides. Make sure that you're showing all of your work. So then 3 equals b. Alright, so if we were to put it all together, then we would get y equals 2, your slope, x, plus your b, which is 3. So let's try to sketch that out. As I mentioned, your y-intercept is 0, 3. So this is 3. Then what your slope does, I'm going to put this 2 over 1 because that's the exact same thing as 2. What your slope does, right here you can see, is your slope max, it lays out basically a compass, if you will. It says that you're going to go 1 in the x to your next point. So you're going to go 1 in this direction. And then it says go 2 up in the y. So you go 1, 2, like that. And so if you were to connect these 2 dots, I have a hard time there, then you would have the line that's associated with those 2 points. So this line is y equals 2x plus 3, like that. Okay, a couple of things that I want to point out that's also in your notes. Notice your slope is directional, right? It tells you what direction you go in the x relative to where you're going to go in the y. And so this is called a rate of change, right? It's telling you how your function is changing. Go 1 right, go 2 up. So every time you use the slope, you should realize that that is biconditionally the same thing as rate of change. Okay, I'm going to be using these interchangeably. No pun intended. Okay, so in your notes I point out that there are 4 different types of slopes, and so I'm just going to show you your notes briefly. So here's the first one, right? So if your function is moving upward as you move right, then you have a positive slope. So you have a positive slope if your function slants in that direction. If your function moves downward as you move from left to right, then you have a negative slope. So again, if your function is moving downward, negative slope. If your function is not moving up or moving down and you have a horizontal line, then you have 0 slope, right? And you can kind of see that if you do the math. Notice I've given you 2 points, 1, 9, 15, 9. So 9 minus 9 all over 15 minus 1. This equals 0 over 14, which is 0. And then here's the last option. If you have a vertical line, and I've done the work for you here for these 2 points, 13 minus 4 for change in y all over 2 minus 2. Notice the 0 is in the denominator and your slope is undefined.